Let's just jump right into this explainer, because today we're tackling a thought experiment that is honestly completely mind-bending. Picture this, a tiny, everyday sewing needle striking Earth, but it's moving at the speed of light. I know, it sounds exactly like the plot of some crazy sci-fi blockbuster, right? But physicists actually use extreme hypotheticals just like this to test the absolute limits of kinetic energy and the fundamental laws of our universe. Because when you take a tiny object, something you'd literally lose in a haystack, and accelerate it to the ultimate speed limit of the cosmos, the normal rules of classical physics, they just completely break down. We're going to walk through exactly what would happen to our planet, step by step, and trust me, the results are absolutely staggering.
Think about the sheer contrast here for a second. On one hand, you've got your standard sewing needle. The mass is basically negligible, right? Maybe a fraction of a gram. You drop it on your foot, you don't even feel it. The impact is zero. But apply a little relativistic physics, accelerate that exact same negligible mass to roughly 300,000 kilometers per second, and suddenly, we aren't just making it fast. We're turning a totally harmless microscopic piece of metal into an apocalyptic weapon of unimaginable power. You see, in physics, kinetic energy isn't just about how heavy an object is. Velocity is a massive part of the equation. And when that velocity reaches the speed of light, the energy involved literally approaches infinity.
So, let's put the abstract math aside for a minute and ask the real question. What actually happens when this hyper-fast projectile hits a densely populated target, like, say, New York City? Picture a totally normal Tuesday afternoon, and suddenly, without any warning whatsoever, and I mean zero warning, because nothing can travel faster than the light that would actually warn us, the needle makes contact with the atmosphere directly above Manhattan. What exactly does that first fraction of a second look like?
Let's break this down chronologically, and we're talking mere fractions of a second here. At just one single microsecond, we get atmospheric entry. But it's not like a normal meteor burning up in the sky. The needle is moving so incredibly fast that the air molecules in front of it simply don't have the time to move out of the way. They fuse. Then boom, by 10 microseconds, this extreme friction and fusion triggers an instantaneous, blinding electromagnetic burst. And by 50 microseconds, we've already got a massive, rapidly expanding plasma shockwave. Notice we aren't even talking about a full second yet. Literally, in the time it takes a single neuron to fire in your brain, this needle has already unleashed an unstoppable chain reaction of pure destruction.
So the really crucial point here is understanding why this all happens. It comes down to a process called atomic breakdown. Because the needle is traveling at the speed of light, the kinetic energy is just so extraordinarily intense that the fundamental bonds holding matter together simply can't hold up. The atomic structure of the needle itself, along with the oxygen and nitrogen atoms in the surrounding atmosphere, absolutely disintegrate. They're literally ripped apart at the subatomic level. And when you break atomic bonds with that kind of brute force, it releases an absolutely unfathomable amount of power. It's essentially an uncontrolled, spontaneous nuclear reaction, but on a scale that completely dwarfs our most powerful weapons.
Because of this intense atomic breakdown, we're not dealing with a standard physical collision here. The needle doesn't just hit the ground and make a crater or actually scratch that. Before it even technically touches the pavement, the entire geographic area of New York City is instantly vaporized. The city, the massive skyscrapers, the bedrock below, the surrounding water, everything is instantly transformed into a terrifying state of pure scorching plasma. As a quick refresher, plasma is that superheated soup of charged particles, the fourth state of matter. So New York simply ceases to exist as physical matter, instantly becoming a localized miniature star burning right on the surface of the Earth.
But here's the crazy part. That localized fireball we just talked about, that is merely the catalyst for a much wider, horrific sequence of events. You have the instant creation of that localized pure plasma, which is followed immediately by a massive, completely uncontrolled release of pure kinetic energy. This triggers a wave of blinding, absolutely lethal electromagnetic radiation that flashes right across the entire horizon. But honestly, perhaps the most terrifying physical fallout is completely invisible: violent gravitational waves. The sudden, violent disruption of all that mass and energy literally sends violent ripples through the fabric of spacetime itself, radiating outward from ground zero.
299,792, that is the exact speed of light in a vacuum measured in kilometers per second. It's the absolute hard speed limit of our universe. And because our needle is traveling at this exact speed, when we sit down and try to calculate the kinetic energy of the impact using standard physics equations, the math pretty much just breaks. The energy yield is a number so incredibly vast, so filled with zeros, that it completely shatters our standard understanding of planetary impacts. It's a velocity that takes a tiny sewing needle and turns it into a literal cosmic wrecking ball.
Just to really put this energy into perspective for a second, think about a massive meteor impact. That leaves a huge crater, right? Or think about our most powerful atomic weapons, which are obviously devastating on a human scale. But this light-speed needle, it completely and utterly dwarfs both of those, shooting entirely off the scale. We're not just talking a little bit bigger here, it is exponentially larger. It's quite literally the difference between lighting a match and flying directly into the center of the sun. The sheer scale of energy release is truly beyond human comprehension.
So looking at energy levels that staggering naturally begs a pretty grim question. Is the rest of the globe doomed? I mean, sure, we know New York is now a plasma fireball, but is the devastation strictly contained to that one impact zone? Does a localized strike at the speed of light just act like a really powerful local bomb, or does it trigger something far worse for anyone living on the other side of the planet?
Well, unfortunately, there's absolutely nowhere to hide. The destruction aggressively scales up. At ground zero, like we discussed, you get immediate evaporation into pure plasma. But globally, the sheer raw output of energy creates lethal radiation that basically cooks the atmosphere. And that's combined with those violent gravitational waves that immediately begin tearing at the Earth's tectonic plates. And incredibly, it doesn't even stop there. The energy release is so massive that it affects the entire solar system, causing complete gravitational destabilization. The destruction scales outward at a completely terrifying pace.
You can actually track this planetary death almost like a horrifying step-by-step narrative. First, that extreme electromagnetic radiation wraps around the globe, superheating the atmosphere to the point that the global crust literally liquefies. The surface of our planet becomes a churning ocean of magma. Then, those violent gravitational waves we just talked about, they travel right through the planet, rapidly compressing and expanding the matter inside until they violently shatter the Earth's iron core. The planet totally loses its structural integrity. And finally, as the Earth blows apart, this massive, sudden shift in planetary mass completely destabilizes the surrounding space.
This destabilization hits our cosmic neighborhood from basically 3 distinct angles. Roughly a third of the chaos comes directly from the suddenly missing Earth mass. I mean, when Earth blows apart, the delicate gravitational dance of the solar system is instantly thrown off balance. Another third comes from those errant gravitational waves, which severely warp planetary orbits. And the final third? That's the outward expanding plasma from the blast itself, sweeping across the cosmos. This sudden, incredibly violent removal of Earth's mass creates a gravitational vacuum that throws surrounding moons and neighboring planets into absolute uncontrolled chaos.
All of this leads us to a pretty chilling conclusion from the source material: the complete destruction of the solar system. Let that sink in. This cascading release of extreme energy wouldn't just end our planet. By ripping a hole in the gravitational fabric and sending out this unstoppable shockwave of plasma and radiation, it would theoretically trigger the total annihilation of our entire solar system. Neighboring planets wouldn't just get bumped, they'd be knocked completely out of orbit, violently colliding with one another, or just being flung out into the deep freezing void of interstellar space.
Okay, everyone, take a deep breath. Before you start nervously looking up at the sky, wondering if a stray needle is hurtling towards us from deep space right now, remember this. This is entirely theoretical. It's a purely hypothetical scientific thought experiment. The truth is, nothing with mass can actually reach the speed of light. It would literally require an infinite amount of energy to accelerate it to that point. Physicists just use this extreme scenario as a really fascinating tool. It helps them stretch the limits of kinetic energy formulas and gain a better understanding of the incredibly complex mathematics behind relativity.
But honestly, it does leave us with a pretty thrilling final thought, doesn't it? If the math behind something as simple and tiny as a sewing needle can theoretically predict the utter annihilation of an entire solar system, what other incredible universe-breaking secrets are just waiting to be discovered in the laws of extreme physics?